now we're going to talk about section 5.1, and this is going to be dealing with elasticity. So elasticity is really going back to supply and demand. Now that we know that, we know prices and quantities. Now, have you ever wondered when would you stop buying something? Like, for instance, if the price of Amazon Prime membership had increased, would you still buy it? And the law of demand would say that you would buy less, and that could be true, right? But what if the price increased again? Do you buy it this year, or do you not buy it this year? Like, basically, what is that point to where you decide not to buy it? Or if we're trying to buy apples, right? If the price were to increase on apples, how many less pounds of apples are you buying? So the elasticity is going to be measuring how much your demand or quantity demanded is changing because of a change in price. So it is an economic concept that measures the responsiveness of one variable to a change in another. Basically, when price changes, how much does quantity change? Now, I'm not looking for, okay, I used to buy 5 pounds of apples, now I buy 2 pounds of apples. That's not what we're looking for. We're trying to figure out how sensitive you are. Basically, not just because, what we're trying to figure out is because the price changed this much, like 10%, because price changed 10%, how much does your quantity change 10%? And because those two are happening at the same time, what is that number? And that number is going to give us a few bits of information that's going to be very useful to tell us what kind of product it is. And it's also going to help a business understand how can they maximize revenue. And I'm supposed to get to that in a second. So price elasticity is a ratio. And if you don't know what a ratio is, I like to think about it this is like if you were trying to make bread, okay, you need flour and water. Okay, and a ratio would be 2 parts flour for 1 part water. And if you don't understand what that means, let's say you need 2 pounds of flour, and how many pounds of water would that be? 1. So we would need 2 pounds of flour, 1 pound of water. So that's a ratio. All right. And so when we're dealing with price elasticity, it's the same thing. But instead of flour and water, we're going to be dealing with quantity and price. So it is the ratio of the percent change in quantity demanded divided by the percent change in price. So that's all we're doing. If you don't understand ratio, forget about it. Okay? It is a ratio, but I don't want to confuse you here. All it is taking the percent change in quantity divided by the percent change in price. That is what we're doing here. So if we're talking about demand, guess what we're going to be using? Quantity demanded. So we're going to be looking at the percent change in quantity demanded divided by the percent change in price. If you're looking at supply, you're going to be looking at the quantity supplied. Same idea, right? Where we're looking at the percent change, but now you're going to be using quantity supplied. So elasticity is the percent change. This is different from the slope of the graph, right? And it has a different meaning. So the slope of it, you're like looking at it, it's like, okay, well, slope is rise over run, right? So that's how much it changes because price changes. Yes, that is true for slope, but the price elasticity is a little bit more specific in how much did that change. So it's going to give you more information, more useful information. So let's look at some examples of elasticity. So, well, I'm sorry. Let me go through the formula again real quick. So when we're talking about percent change, because a lot of people don't understand what percent change is. So percent change is this. Let's say that the price like the old price, was $5. And then at this price, people bought 100 pounds of apples. Then prices change. So we have a new price. Let's call it 7. quantity demanded would go down. So let's say it's 80. So here's the situation. We have a price and quantity. We have an old and a new. Percent change is looking at the change between price and quantity, and we're going to use it as a percent. The percent is going to basically let us know how much it changed. Because going from 1 to 2 is a change of 1, but a percent change is 100%. And the 100% is really going to be useful in these situations. So, with that being said, percent change here is new minus old divided by old. So if I were looking for the percent change in quantity, I'm going to take the new quantity minus the old quantity divided by the old quantity. So let me show you there. If I wanted the new quantity, that would be 80. So I would do 80 minus the new, which is 100. And then I would divide this by 100. And that would be my old. Okay, so the new minus old divided by old. 80 minus 100 divided by 100. Okay, now if I were to do the math here, that would be 80 minus 100. That's negative 20 divided by 100. And if you put this in your calculator, that's going to be negative 0.2. So instead of quantity, you can say quantity decreased by 20 pounds, or you can say it decreased by 20%. Sometimes the percent really helps us understand if we're able to compare how much it changed. Because if you wanted to look at gallons of gasoline and pounds of apples, those are two different measurements, pounds and gallons. But if we look at the percent change, we can understand how much it changed. It gives us a little bit like an understanding of how we can see things change. Now let's do price real quick. Same idea, percent change in price. So we're going to do new minus old divided by old. So that'll be 7 minus 5 divided by 5. So that'll be 2 divided by 5, and that equals 0.4. So now price changed 40%. So now let's do the elasticity. So elasticity, or the price elasticity of demand, PED, in another world that would be performance enhancing drugs. But in economics, that's going to be price elasticity of demand. So therefore, it's going to be percent change in quantity, percent change in price. The quantity was negative 0.2, and then the price was 0.4. Okay. If you were to put this in your calculator, you should get negative 0.5. And let me double check that because I don't trust myself sometimes. Yes, 0.5. So that is the price elasticity, negative 0.5. Okay. What does that mean? I'll tell you in a second. But the main thing is we're looking at the new minus old divided by old. We're going to do that for quantity. We're going to divide that by the price, and then we can get the elasticity. We'll do plenty of examples, so you'll be able to see how this works. But that's how you calculate price elasticity. Let's look at some examples. So there is a thing called a sin tax on cigarettes. And basically what we're trying to do here is the governments use a tax in order to decrease the use of cigarettes. So states could have a tax on cigarettes as low as 17 cents per pack, like in Missouri, or they could be $4.35 per pack in Connecticut. Okay, so different states have different levels of taxes, And as we know with taxes, the more you put on it, right, the less you're going to buy. So let's look at this. If the federal government were to currently raise the $1.01 tax on cigarettes to $1.95, how much would the purchases change? Okay, so looking at your consumers, okay, and then the taxes change, they go higher, you would expect them to buy less. But let's think about something addictive like cigarettes real quick. There might be some people that will not buy cigarettes anymore, and there will be people that will maybe buy one less pack per week. So we will be having maybe a big change in price, but a very little change in quantity. And so that is the kind of like, what are we trying to do here? Okay. Are we trying to decrease the amount of cigarettes people are buying, or are we trying to do something else with the tax? Because taxes serve two purposes in this case. Taxes, number one, are used to raise tax revenue for the government. So basically, the government needs money, so they tax products in order to get extra money from you, or they are trying to discourage cigarette consumption. So the elasticity is going to basically tell us if the price changes, how does this change your total revenue? And it's also going to tell you how responsive people are. Okay, basically, because the price goes up, you know, from $1.01 to $1.95, are we having a big decrease in quantity or a little decrease in quantity? And that's what we're going to figure out here. Because if that is the purpose of cigarettes, to raise revenue and to decrease consumption, why not raise it? Like, what would be the issue there? One issue would be, you know, people would be like, well, why is the government trying to tell me what I could consume? Right. Okay. Why is the government trying to, get tax revenue from this? Why can't they get it from something else? Right? There are different reasons why maybe they shouldn't raise it. Um, but you can think of your own idea why they shouldn't. Um, like, why would we increase it so much? What would be the gain there? What would be the loss there? There's a lot of things to think about here. So let's go into what is going on with elasticity. So the formulas are scary for some people, but don't worry. It's the percent change in quantity divided by the percent change in price. So that number we did earlier, that 0.5, we did the math for it. Now, what does that mean? So there are three types of some elasticity. Number one is elastic. Now think of something as a rubber band as being elastic. And what can you do with an elastic rubber band? You can really stretch it, right? So what would that mean for the percent change in quantity? Because the price goes up, we're going to have a big change in quantity. So if it's a big change in quantity, that's going to be something that is elastic. How do you know it's elastic? You're going to do the calculation, and you're going to get a number that is greater than 1. So 1.5, 5.5, 5.4, 1.01, all of those numbers are going to be elastic because they are greater than 1. And so the number we got earlier was 0.5. Is 0.5 greater than 1? No. So it is not elastic. And so what about equal to 1? Equal to 1 would be unitary elastic or unit elastic. Unit elastic. When something is unit elastic, what that means is that your quantity goes up 10% and your prices go down 10%. So They basically change the same. So that would be unit elastic. That would mean what is left is a small change in quantity, something that is inelastic. Like you can't, really stretch it out. It's inelastic. So small change in quantity, and that's going to be something that is less than 1. So when we did the calculation earlier, up here, okay, this complicated example here, and we got 0.5. This is going to be something that is inelastic. Why is that? Why is this inelastic? Because when we did the calculation, right, we did the percent change in quantity, percent change in price, we saw that to be negative 0.5. So 0.5 is less than 1. Now, if you're wondering the negative, okay, I love it where you're thinking. So with demand, if price goes up, quantity will always do what? Go down. So you'll always have a negative number, right? So because you'll always have a negative number, what we'll do is we'll take the absolute value of the number. That way you won't get confused about is it less than 1 or greater than 1. So always take the absolute value when you're doing elasticity, because when you do that, you turn a negative 0.5 into 0.5. And now you can see, is 0.5 elastic or inelastic? And it's going to be inelastic. Another way to think about something that is inelastic, it's 0 point something. Okay? 0 point something. That is inelastic. So 0.9, 0.5, negative 0.9, negative 0.5, inelastic. Okay? If it's 1 point something or more, like 2 point something, negative 2 point something, that's going to be elastic. So it goes both ways. Negative 5, inelastic, elastic. Okay, well, we take the absolute value. So negative 5 takes the absolute value, turns into 5, and 5 is greater than 1. So that would be elastic. So 1 point something or 2 point something, that's going to be elastic. So those are the different types of goods that we have based off of that number. And what we're doing here is we're just basically seeing, is it having a big change in quantity, small change, right? And with that information, that's really going to tell us what would happen to the market if you tried to raise price. So something that has elastic demand, and you were to increase the price of your good, a lot of people would not want to buy. Okay. But what if it was something that a lot of people need, like medical care? Like if something like medical care came up and they tried to raise the price of medical care, I mean, are you just not going to buy medical care at all? You might try and buy a little bit less, but you still, a lot of people still need it. So we might have inelastic demand for something like medical care, because even though the price goes up, we have a little change in quantity because a lot of people need the medical care. So the quantity is not going to change as much as something that, let's say, luxury cars. If luxury cars increase their price 10%, a lot of people are like, you know what? No, I'm not going to buy it. So big change in quantity, something that's elastic. So we'll definitely look over some examples. Now, the formula for elasticity: percent change in quantity, percent change in price. What if I told you there was another one? That could scare you, okay? But let me just talk you through, okay? So we already talked about how that's the new quantity minus the old quantity divided by the old quantity. That's the percent change in quantity. And now we have the new price minus the old price divided by the old price. So that's what we have here. Okay. And then we're going to divide those two, and that gives us elasticity. So that's what we did earlier. Now all we're going to do is we're going to add something to it. Okay. So instead of new minus old divided by old, we're going to be doing new minus old divided by average quantity, or new minus old divided by average price. So in that case, the percent change in quantity using the midpoint method, all we're going to do is new Q2. So new minus old divided by average. So when I say average, what we're doing is we're taking the new plus old divided by 2. Okay, that's what we're doing. So using the midpoint method, you will have new minus old divided by the average, so new plus old divided by 2, and then we'll have new price minus the old price divided by the average price. Okay. So that is the midpoint method. The midpoint method, where we're taking the average. This is a great way to basically look at the average change between 2 points. Because economists use this as a way to basically say, well, if the price goes from here to here, elasticity is 5.5. But elasticity from here to here is different. So there are different numbers in between the 2 points. Like the numbers are the same, but the way you calculate them are going to be different, so the numbers are different. So that's why we like to use average, so we can get the average change between 2 points. And I'll show you for an example. So let's calculate the elasticity from B to A. B to A. All right, so that's right here. Okay, so this is the quantity, and this is the price. Quantity, price. So we're going from B to A. From B, so we're leaving B behind, and we're going to A. So what is old in this situation? I'm leaving B and I'm going to A. So the old is B, the new is A. So new quantity is going to be 3,000. Old quantity is going to be 2,800. Okay. So when we're doing the elasticity formula, we're going to be doing new minus old divided by old. New minus old divided by old. So that would look like this. We would have new, old, old, boom. That gives you the percent change in quantity. Now we're going to be dividing that by the percent change in price. And the percent change in price is new and old. So 60 minus 70 divided by 70. Okay, so that will be the percent change in price. Okay, so now let's calculate this thing. So on the top here we have 3,000 minus 2,800. That is equal to 200. We're going to take that divided by 2,800. Divide that by 60 minus 70. All I'm doing, okay, if you're confused about where we're at, okay, go top down. New minus old, okay, 3,000 minus 200, 2,800, okay. Find out what that is, 200. Divided by old, so 2,800. Divided by new price minus old price, so 60 minus 70, negative 10. Divided by the old price, which is 70. Okay, so Okay, so all I'm doing is I'm just going straight down. Make it simple. Okay. All right, now I'm going to go straight down again. Okay, so 200 divided by 2,800. So that's all I'm going to do. I'm going to do 200 divided by 2,800, and I'm going to get a scary number, 0.0714. Ugly. Now, so that's done. So now I'm going to go down again, and I'm going to do negative 10 divided by 70. So that'll be 0.1428. I like using 4 decimal places. This gives me a this is going to give me to the closest answer possible. Now, I could use more decimals, and I would get even closer to the right answer, but 4 decimals will get me pretty close. So if I use 4 decimals, all I'm going to do is do both of those ugly numbers and divide them. So I'll take 0.0714 divided by 0.1428, and that should be 0.5. Now, is that positive or negative? It should be negative, right? Because we got negative 10 divided by 70. So it should be negative here. So that'll be negative over here. So negative 0.5. If you are confused, please start over. Please rewind a little bit and rewatch it again. All it is going top down. You should get negative 0.5. Now, what do we do with that information? What kind of good is this? Is it elastic, unit elastic, or inelastic? It's greater than 1? No. It's 0 point something, and 0 point something was inelastic. So this is an inelastic good. Okay, so going from B to A, it's inelastic. Now, what about the midpoint method? Okay, what's different there? We're not using old, we're using average. So let's take a look at what that means. So I'm going to do a new page here. Okay, add page. All right, so let's talk about it. So I'm going to write down all my information. So old was, 3,000. And my old price was 70. Sorry, I'm trying to remember off the top of my head. And new price was 60. And okay, so those are our numbers. Oh, did I flip them around? 70 and 60. Ah, okay, so right there. Okay. So new and old. Oh, sorry. Okay, now we're good. So, new, old. So now that we have those correct, let's do the midpoint method. And let me write down the midpoint method again. We're going to do new minus old divided by average. New minus old divided by average. So all we're going to do is take in the information from the left and put it in on the right. So that'll be 3,000 minus 2,800 divided by the average. And to find average, you add and divide by how many you have. So it'll be 3,000 plus 2,800 divided by 2. So that should be 2,900. You add them together and divide by 2. Now we need to do new price, which is 60 minus 70 divided by average price, which will be 60 plus 70 divided by 2. So it should be 65. Add together, divide by 2. Now, all we're going to do is go straight down again. And so now we'll do 200, 3,000 minus 2,800, that's 200, divided by 2,900, divided by negative 10, divided by 65. I will now be doing 200 divided by 2,900, and that is going to be a ugly number. I'm going to put an extra decimal there, and I'll tell you why. And then, so I put an extra decimal there because, you know, I just want to show you that, I mean, you can do as many decimals as you want. I do 4 most of the time. When it comes to like 9/6, where you're rounding up, and you want to put the extra decimal there, or yeah, the extra point there, no problem there. If you wanted to round up, and you wanted to do 0.690, you can do that too. But I wanted to show you could do both ways. Now we'll do 10 divided by 65, and that's going to be another ugly number. Okay, and now all we'll do is those ugly numbers divided by 8. And if you think they're pretty numbers, they are in their own way. Alright, and this should be a negative number. But that doesn't matter, right? Because we're going to take the absolute value, or field goals, right? So, negative 0.4486. So that is going to be our price elasticity of demand using the midpoint method. And so see how we're getting 2 different answers here. Okay, so one, 0.5, one 0.4486. If you were to go from A to B, so flip it around, you would get a different number than 0.5. So, you know, that's why we use the midpoint method sometimes to get the average between the 2 points. So, you know, kind of basically you get both worlds at one time. So either way we look at this, what kind of good is this? It's 0.44. So that's 0 point something, that is inelastic. Okay, so inelastic. Same thing. Let's do G to H. Okay, let's do G to H using without the midpoint method. So we'll use new minus old divided by old. It's got a good ring to it, right? New minus old divided by old. We're going G to H. So G is G to H. So G is the old, H is the new. So see how I did the thought process? G to H. G is the old, H is the new. So new, old. G to H. Nope. There we go. See? It has to make sense. Okay? G is the old, H is the new. Okay? Even I make mistakes, right? But then I have to check myself. Okay? New, old. Okay? Old, new. G, old, H, new. Okay? G to H. Always double check yourself. So now we have the quantity. So Q old is 1800, and then Q new is 1600. P old is 120, and P new is 130. Okay, so we're going to take these numbers and go down here. Okay, so now we'll do the price elasticity. So we'll do new minus old, so 1600 minus 1800 divided by new minus old divided by old, which is 1800. And then we'll do new minus old 20 divided by 120. We'll go straight down. We'll do negative 200 divided by 1800. 130 minus 120 is 10, and then 120. And so if we did those numbers, negative 200 should be negative 0.1111, and then we should have, that's not right, okay, 0.083 3. If you put that into your calculator, you should get negative, right? Negative 0.111 divided by 0.083. You should get negative 1.3337. So, what kind of good is this? If your answer was inelastic, what did you forget to do? We have to take the absolute value, and that'll give us 1.337, and 1 point something is elastic. Okay. Elastic. Okay. So that is how we do price elasticity of demand. To do price elasticity of supply, all we would do is do the same thing, but now we would get a positive number. So that makes it a little bit easier. So if we did from A to B, okay, you would do the quantity, which is 10 minus, let's say it's 12. If you disagree, that's fine. All right, let's say it's 12. And then we did 650. So 700 minus 650. Hold on, I mixed that up. Sorry. We're going A to B. So the new is B. So that would be 12 minus 10 divided by 10. If you caught me, good job. So then we'll do 700 minus 650 divided by 650. And so what is the price elasticity from supply from A to B? You should get okay. 2.6. Something like that. Let me double check that. 0.769. Yes, you should get 2.6. Okay. So that's how you calculate elasticity. Percent change in quantity divided by percent change in price. So what kind of good is this? It's 2 point something, so that would be elastic. Okay. Alrighty. So if you have any questions, there will be some review questions, so we'll be able to do that. And we'll just keep practicing. Okay. If you want to watch the video again, please do. Okay. So I'll see you in section 1.2. I'll see you there.